Hey everyone, and welcome to Geometry Lesson 5. How did you guys go with question 5 from Geometry Lesson 4? So I told you needed to prove triangle BOP and AOP were congruent. So you should have started by saying in triangle BOP and triangle AOP, comma. And you could have said that OB equals to OA, reason being they're actually equal radii of a circle. So when you have a circle, the radius are both equal from the center to the edge. You could also say that angle B equals to angle A, which is 90 degrees, and that's actually given to you in the picture. Oops. I meant to write given, not pick. So you can write given there. But what I meant was by given is that it's actually given to you in the picture here. Okay, and then we can also write down that OP is common. Or it's shared, okay? And therefore, you've shown three things. So triangle BOP is actually congruent to triangle AOP. And the test I used would be RHS, because the right angle, the hypotenuse, and the side are equal. Now, since that is the case, I can say, therefore, BP is equal to AP, and my reason is classic matching sides in congruent triangles are equal. Okay, so that's what you should have had. So write that down if you didn't get it. But we need to move on to today's section of work, or this section of work, on similar triangles and ratio of intercepts. So the similar triangles stuff you should know. So you should know the tests and what it means for triangles to be similar. Also properties of transversals with parallel lines, and ratios of intercept. This is kind of a new concept in this course that you probably haven't done before, so that's a new little bit. Okay, so for similar triangles to exist, basically there has to be all matching angles equal and all matching sides in the same ratio. Okay, and the following conditions could exist. So they're kind of like three tests. Here they are. The first one is three matching sides of one triangle are in the same ratio to the other. Then they're similar. Also, if we've got three angles of one triangle equal to three angles of the other, they're also similar. And there's an example of the second one here, so you can see that you've got these two angles equal, so the third must be by default. We don't really talk about equiangular, so some books you'll see equiangular. We don't write that, okay? We just write down three pairs of matching equal angles. And the third thing is you could have two sides of one triangle in the same ratio. So in the same ratio, that's another way to say proportional. And the included angles are equal. We talked about what included angle means in congruence. It means the angle in between the two sides. Okay, so moving on to our first example. It says in this diagram, DE is parallel to BC, and you can see that with the sign given here. On the 2 and the 6, and then it says prove that triangle ADE is similar to. Okay, now that just means the symbol with three vertical lines, that means is similar to. So you kind of need to make sure you know that and write that down if you didn't. Then it says list the corresponding sides and the corresponding angles. Remember, those should say matching. And then find the value of y. So to prove they're similar, we're going to start off the same way as a congruence proof. So we're going to go in triangle ADE and triangle ABC. I'm going to write angle A is common because it's this shared angle at the top here. Then I'm going to say angle ADE equals angle ABC, and angle AED equals angle ACB, and my reason for both of those are corresponding angles on parallel lines are equal. So the cool thing is I don't even have to find out what they are. I can just know from this theorem that that's true. Okay, and so basically what I've shown is 3 pairs of matching equal angles. So, and that's kind of what I'm going to say now. So I'm going to say since three pairs of matching equal angles exist, triangle ADE is similar to triangle ABC. Fantastic. Now, the next part of the question actually asks me to list the matching angles and list the matching sides. So in that part, you would basically write down, so this is for B. For B, you would have to write down angle A is common, because that's shared. You would then write angle ADE is equal to angle ABE, and angle AED equals angle ACB. Okay, so if you want to know what all that means, going back up to the picture, we're seeing here that there was an F shape here, and there was also an F shape here. Okay, so in other words, these two angles are equal and these two angles are equal here, and that's what we've written down. Nice. Okay, the last part of the question says find the value of y. So for this section, which I'll do up here, I can use the ratios of triangles to do this. So I'm going to go y over, so the big side here over the small side 8, y over 8 equals the big side 6 over the big side 2. And I'm going to go y equals 3 times 8, which is 24 centimeters. And that's the first question done. Okay, so have a read over it again, copy it down, write down any questions you might have for me later. Okay, the second question is a bit different. It says prove the line joining the midpoints of two sides of a triangle is A parallel to the third side and B half of the length of the third side. So the first step in this problem is to actually, for part A, is you have to actually join the points MN, and I've done that for you in the picture here already. You can see that MN here has been joined. That wasn't in the question to begin with. Okay. The next thing I need to do is write down the ratios of things. Okay, so in both these triangles, so in triangle AMN and triangle ABC, what I can say is that AM over AB equals AN over AC, and that is exactly 1 over 2. It's half the length, okay? And the reason I can say that is that M and N are the midpoints of sides AB and AC. Okay, and that means they cut them in half. So I'm going to say angle A is common. And so what I've done is prove they're similar. So therefore triangle AMN is similar to triangle ABC. And my reason is two matching sides in the same ratio and their included angles equal. Okay, so that's the first bit there. And that shows me that for part B then, MN is equal to half BC. So this next section is on ratio of intercepts, and it's a new concept, but basically all it's saying is that if you look at this picture here, that A over B, so this section here, A over B, is equal to, AB over BC. AB over BC is equal to DE over EF. Okay, and when you write that out, you get this here. So that's when two or more transversals cut the parallel lines. Transversals are just the lines that cut the parallel lines. So let's have a look at some examples, easy ones. And they don't get much harder than this, to be honest. So they want me to find the missing pronumeral. So what I'm going to do in this one is I'm going to write 5 over 3 is equal to y over x, but you'll realize that I can't really do that. There's two unknowns there. So I'm going to start with the bottom two. So I'm going to go x over 8 is equal to 3 over 4. And I'm going to times the right hand side by 8. So x equals to 6. Okay, because if I times 3 by 8, I get 24, and 24 divided by 4 is 6. So that's one answer. Then plugging that in, I get 5/3 equals y on 6 times both sides by 6, and you get y is equal to 10. Okay, so those are my values of x and y there. Nice and easy. The next bit you're going to do exactly the same thing. So in this problem, I'm going to go 4 over 12 is equal to 9 over x. And I'm going to go, simplify the 4/12, so that's 1/3 is 9 on x. And in this one, I've got x is equal to 27 when I cross multiply. Okay, so in this section of work, we looked at ratio of intercepts and we looked at similarity proofs. Write down some summary points, any questions you took away from this video lesson, and try the homework as well. Thanks, everybody.